now is this question 5, a model for the population, right? K of kangaroos is this, where T is time in years from today. Show that K satisfies the differential equation. Yes, you can differentiate this straight away, I guess, and rearrange continuously, but I think it's going to take too long. So again, my suggestion will be, let's do something special. We know that dk on dt, right? dk on dt, I think we all done the differential equations before, that we can have another variable, dk on du, right? And du on dt, splitting it into 2 parts. And over here, what I should do is let u equals to 7 plus 3e minus t. It's a bit hard for me to write. Right, minus t on 3. Okay, so my du will be negative 1 on 3, 3e minus t over 3 times dt. So what I get is minus e minus t on 3, right? This is just my du on dt, or instead of putting the dt on the other side, right? Okay, so now let's differentiate k in terms of u, and then chucking in the du on dt. So dk on du, right? I let u equals to 7 plus 3e minus t on 3. That means I will be differentiating. So let's rewrite my k first. My k will be equal to 21000 over u. Okay, and now I'm differentiating my k in terms of my u. I'll have 21000 u minus 2, dropping the minus 1 down, right? So I get minus 21000 u minus 2. Now let's sub the 2 parts in. So what I get is equal to dk. Subbing in. So I get negative 21000 u minus 2 times by my du on dt, which is minus e minus t on 3. Okay, so now we have everything set up. Let's change my u back. So what I get is minus 2. Simplify first. I got 2 negatives. I can cancel them out. So I get 21000 u minus 2 times e to the power of negative t on 3. Okay, so the 2 negatives over here and over here will cancel out. And then putting everything top, 21000 e negative t on 3 over, right, subbing the u back. So what I will get is 7 plus 3 e minus t on 3, but this is square. Okay, up to this point, you're going to leave it here and then start proving what dk on dt, the formula they've given you, is going to be equal to. So over here, you should start on a new line. Dk on dt is equal to 1 on 3, 1 minus k on 3000, 3000 times k, right? This means is equal to 1 minus, right, your k, subbing your k in, 21000 over 7 plus 3 e minus t on 3 over 3000 times by the 21000 over 7 plus 3e minus t on 3. Okay. Now, I'll do the simplify. So 1 minus 21,000 over 3, dividing by 3,000, that just gives me 7. Yep, I get 7 on 7 plus 3e minus t on 3. Right, and then over here I still get 21000 over 7 plus 3e minus t on 3. Now simplifying the middle part, I get 1 on 3, 1 minus 7 plus 3e minus t on 3 minus t over 7 plus 3e minus t on 3 times in by 21000 over 7 plus 3e minus t on 3. What I will get is 1 on 3, 3e minus t on 3, 7 plus 3e minus t. Right, on 3, I'm going to make this times the top two together. So I'll get 21000 also inside, right? And essentially the top 3, I'll use the red color. Top 3 and bottom 3 will cancel out, and I'll be getting 21000 e negative t on 3 over 7 plus 3e minus t on 3 squared. And this is essentially the same thing as our dk on dt of over here, right? And then now that's part 1 down. 2, what is the population today, right? If it's asking what is the population today, we know that it says where t is in times in years from today. So actually today will be t equals to 0, right? I'm running a bit out of space, so I'll do it here. 2, t equals to 0, then essentially my k is just equal to 21000 over 7 plus 3e, right? Negative t on 3, but t is 0, so essentially the whole thing is 0. So I'll be have 21000 over 10, right? Which is 2,100, right? That's the kangaroo population today. All right, now part 3 says, what does the model predict that the eventual population will be, right? Part 3, over here, essentially we'll have t approaching infinity, right? When t approaches infinity, we know that e to the power of negative t on 3 will actually approach, e to the power of negative t on 3 will be approaching 0, essentially, right? Because e to the power of t will approach infinity, but e to the power of negative t will approach 0, right? You can put it in your calculator, right? If you put e to the power of negative 9999999, which is 1 on et, right? And you will essentially get 0. So knowing that e to the power of negative t on 3 will approach 0, this gives us our k is equal to 21000 over 7 plus 3 times 0. So what I get is 21000 over 7, and which is 3,000. Okay. Lastly, what is the annual percentage rate of growth today? All right. So we need to find our annual percentage growth rate. What it means is how much has grown, right? How many kangaroos, how do I say this? How many new kangaroos are we expecting, right? Next year in comparison to this year, like how many new kangaroos have been born? So 4, I mean, What we can use is actually the differential equation that we just find. So dk on dt is equal to 103. I'll write it a bit downwards. So dk on dt is equal to 103, 1 minus k over 3000 and times k. So we know that essentially at this year, right? At this year, we have a population of k, which is equal to 2,100, right? So subbing that in, I know that at this year, I will have a gradient, which means 21000 on 21000. So I get 700 times 900 over 3000. I'll get 700 on 9 on 30, right? So simplifying that, I should get I'll get 210, okay? This means 200 by using the differential equation or by using the rate, I know that 210 new kangaroos will be our growth rate, right? 210 new kangaroos will be born the next year. So this is the newborns, right? Newborns. This is my growth rate. All we have to find is the annual growth rate. So finding the percentage, so percentage of annual growth rate and growth rate will be equal to 210 over 2,100, okay? Which is, well, times 100% also, times your percentage, 100%, right? The newborns over what we have this year is our annual growth rate, so which is 10%. So we have a 10% growth rate by the next year. We're expecting around 2,310 kangaroos, right?